Welcome to Engineers Mindset. Now let's say we are given to evaluate limit as x tends to 0, y tends to 0 of this given function. Okay, so the first thing as always is to try by direct substitution. Okay, so we simply would put in the values of those limits and test to see if the limit is defined at those points. All right, so first thing, limit as y tends to 0. So I simply send x tends to 0 into a bracket. So x tending to 0, test for it first. All right, so this is x squared minus y squared all over x minus y. All right, so I test when x actually tends to 0 first. So this gives me limit as y tends to 0. Okay, so wherever I see x, simply putting the value as what? 0. All right, so in place of this x squared here, I'll simply have 0 all squared minus y squared all over. In place of this x here, I'll have 0 minus y. Okay, so I have this. So this becomes limit as y tends to 0. Of course, 0 squared gives us 0 minus y squared all over, this is 0 minus y. All right, so at this point now, I'll simply put in my y as what? 0. So whenever I see y in this equation, simply putting the value as 0. So this simply becomes 0 minus, in place of y squared, we simply have 0 all squared all over 0 minus 0. And this is simply 0 minus 0 over 0 minus 0, which actually gives us 0 over 0. And I said in the first video, please do well to look up the introduction video on limits and functions of several variables to properly understand. So I said in the first video that if I have 0 divided by 0, this expression is actually called indeterminate. It's an indeterminate expression. So which means, okay, which means the limit is not defined at what? These 2 points, x to 0 and y to 0, if we go by direct substitution. So we have to try another method and see if there's something that can be done. And after the direct substitution method, the next method to try is called the factorization method. So we'll look at the given function and see if we can factorize this. Okay, so in the first video, I gave a shortcut approach to factorizing this. So I have the function f of xy to be equal to x squared minus y squared all over x minus y. So I said if you want to factorize this, f of xy, okay, so please, I'm using f of xy simply because this function depends on x and y, as can be seen here. There's x here, there's y here, there's x here, there's y here, so it's called f of xy. The function depends on it, so that's why I'm using f of xy. Okay, now this is equal to, if I want to factorize this now, what I'll do is this, simply pull out, I have x squared here, pull out one of the x, so I simply have x, bring the sign, which is minus, and then I also have y squared here, so pull out one of the y, I'll simply have y, close the bracket, open another bracket. Now remember that it was x squared and I pulled that one, so which means I'm left with 1 here, so put that one back, which is x. Now I left the sign, I brought back the sign as what? Minus. Now I'm going to change this sign to be positive, it becomes plus. I also have here y squared, remember I pulled that one, so which means I'm left with 1 here, bring that one back, close the bracket, all over x minus y. So this becomes the factors of this. So if I simply expand this bracket, I'll still have it back to be this. So it means that this function can also be written as what? This function. From here now, notice that x minus y can actually what? Strike x minus y. So this is by factorization method. Okay. All right. So that means by factorization, I simply obtained x squared minus y squared all over x minus y to simply be equal to, so if this strikes this out, I'm left with x plus y, x plus y. So which means the limit now becomes limit as x tends to 0, y tends to 0 of simply what? X plus y. All right. So I'll try the first case when x is 0. That simply gives me limit as y tends to 0. So simply putting the value of x as 0, we are testing for x now. X tending to 0 of the function x plus y. Okay. And of course, this is limit as y tends to 0. Of course, in place of x now, I simply put 0. It becomes 0 plus y, and which is actually what? Y. Alright, so 0 plus y still remains y. So I cannot test for when y is 0, simply putting the value of what? Y as 0. This actually gives me what? 0. So which means the limit of that function as x tends to 0, y tends to 0 of that function f of xy is actually equal to. So notice now that we actually obtain what? 0 rather than obtaining what? An indeterminate expression. So this becomes the answer to that limit. Alright guys, I hope you enjoyed that wonderful video on limits. Please, if you do, share your thoughts in the comment section, and I will see you in the next video with more amazing problems on limits and functions of several variables. Please don't fail to hit the subscribe button if you are new to the channel to get updates on more content like this. Thanks guys, and cheers.